Welcome to The Explainer. Today, we're going to dive into a really clever security feature that's right at the heart of Linux. It's the solution to a puzzle you've probably run into without even knowing it, a kind of paradox that's key to how our systems stay secure.
And that puzzle, well, it all starts with something we've all done a million times, changing our password. Seems pretty simple, right? But have you ever really stopped to think about how it actually works under the hood? I mean, on the face of it, this seems totally impossible, doesn't it? You, just a regular user, somehow need to go in and change one of the most protected files on the entire system. Let's take a look at the evidence. So the file that stores your encrypted password, that's /etc/shadow, is locked down tighter than a drum. It's owned by the super user, root, and as a normal user, you have absolutely no permission to read it, let alone write to it. So how in the world does the passwd command actually work? Well, the solution is this incredibly elegant concept called a SetUID program. See, instead of just giving you all this dangerous power permanently, the system lets you borrow it, but just for one very specific task.
Okay, let's break this down. A SetUID program is a special kind of executable. When you run it, the system basically says, okay, just for the time this program is running, and only for this program, you get to act with the power of the program's owner. You're borrowing their authority, but just for a second.
You know, the best way to picture this whole thing is with an analogy that I think makes it crystal clear. It's like a power suit. You put this suit on to gain special abilities that you just don't have normally.
And this is a really, really important distinction. Is the power something that's just part of you now, like Superman's powers? Or is it a tool that you're just using temporarily, like Iron Man's suit?
A SetUID program is 100% an Iron Man suit. You, the user, you don't change it all. You just put on the password suit to do one specific, powerful thing. The second that program is done, the suit comes off, and all that extra power just vanishes. And get this. This whole idea is right there in plain sight. If we actually look at the permissions for the password command itself, we see two really important things. First, its owner is root, no surprise there. But second, look closer. You see that little S where the execute X permission should be? That's the flag. That S is what tells the operating system, hey, this thing right here, it's a SetUID power. So how does the system actually pull off this identity switch? It's not magic, it's just really, really clever bookkeeping. You see, the kernel is actually keeping track of two different user IDs for every single process that's running on the system. Okay, so you have your real user ID, or RUID. Think of that like your driver's license. It never changes, and it proves who you really are. But then there's the effective user ID, the EUID. That's more like a temporary work badge. It defines what you're allowed to do right this second. Now, for most programs, your RUID and EUID are exactly the same. But for a SetUID program, they're different. So let's walk through it. First, you type passwd. The operating system sees that special S on the file. It then sets your real UID to you, but it sets your effective UID to root. Now, since you're effectively root, the program is allowed to modify the /etc shadow file, and as soon as it's done, the program exits, and your effective UID instantly flips back. Poof, the power suit is off. This is a beautifully secure system, right? But just when we think we've got it all figured out, a whole new character enters the story, and it adds this fascinating layer of complexity. And that character is the environment variable. And this is where things get really, really interesting. The program itself, the power suit, it might be totally secure, but what if you could kind of mess with its behavior from the outside, even while it's wearing that root-powered suit? And that's pretty much the exact job description of environment variables. They're these dynamic settings that live outside of a program's code, but the program can read them and change how it acts on the fly. These variables are absolutely fundamental. They're part of every single process, and they allow for a ton of flexibility. The classic example is the path variable. It's what tells your shell where to look for other programs. So instead of coding in a specific location, a program can just ask the environment, hey, where do I find this tool? So the crucial point here, the big takeaway, is that a program's actions aren't just decided by its code. They can be seriously influenced by these external and often user-controlled values. And that leads us to the big million-dollar question, doesn't it? If a regular user can set an environment variable, and a SetUID program that's running as root decides to read that variable,
Well, have you just created a backdoor for a normal user to influence a root-powered process? This delicate dance between giving power and maintaining security is at the very heart of system design, and it's what makes this stuff so endlessly fascinating.